Hello colleague, here in this watch and learn movie we are going to show you how to generate two separate models in ETABS, and for the sake of design of their common foundation, how to unite all these different two model results in one safe model for the purpose of a matte foundation design. Now please see and observe closely the kind of models we are going to use. This is model A of left hand side building. This is model B of right hand side building. And finally, the building will appear in 3D space the way it is shown here. Now please take note that typically these two buildings in general will be analyzed and designed independently by two separate teams of engineers. Now when we are going to combine these two building results in one safe model, we have to keep a few things in mind. One of them is that this building A may move towards right, building B may also move towards right, or both these buildings may move towards left. Alternatively, these two buildings may move towards each other or away from each other. This we have observed in X direction. Now observe the same thing in Y direction. So now we see that there are several different combinations of the movement of the two buildings. However, when we are having these two buildings as independently analyzed buildings separately, then we cannot combine the response spectrum results of the two models which have been analyzed separately. One option could be that you can generate the model of both the building blocks in the same ETABS model and then evaluate their modal responses and the response spectrum cases you can analyze, and the subsequent results can be directly exported to say for the purpose of design of a basement. But in general, in most design offices, this is not the preferred approach, because this makes the modeling a little complex task, as the two complicated buildings may have to be modeled together at the same instant of time. So we will be using the other approach when the two building models are analyzed separately. Now run the model. First of all, please take a note which particular load patterns have been given: dead, live, earthquake X, earthquake Y. Now let us analyze this building. We are not going to use response spectrum analysis for these two models. Okay, now we have analyzed it, and now we are going to export it to SAFE 12. Store to export base and use second option, export floor loads and loads from above, and then select all load cases: dead, live, earthquake X and earthquake Y. We are naming it as model A.F2K, and we have saved it separately. Then go to model number 2, analyze it. Before we analyze this model, let's have a look on the load patterns defined. Now dead and live, these names are perfectly fine for this model B. However, earthquake loads should be given a new name. The reason is that we may wish to create these loading scenarios in our final safe model, where the building A and building B may move uh, towards each other or away from each other or together towards left or right or up and down. And that will not be possible if we are labeling the load pattern names of EQX and EQY, which have already been used in model A. So we change these labels of only the lateral loads. Next, we are going to change the load case names. Now run the analysis. After running the analysis, use File menu, Export, Story as Save 12.f2k file. Then choose Story Base. Choose second option, Export Flow Loads and Loads from Above. And then choose the appropriate gravity and lateral loads. Press OK. And now give it a name as Model B. Okay. Now we are closing this ETABS. We are closing model A also because we no longer need it. Now please take a point. Now please take a note that this is the final orientation of the two building blocks in ETABS. However, in model B, which is on the right hand side, the origin is having 0, 0 coordinate. But if you see it in the combined building model, the origin is at 24.5 and minus 4. So to regenerate the same scenario, what we will do, we will simply open the save file. We will simply import the two models in save, and there we will be moving the model B joint coordinates by distance of 24.5 and minus 4. You need to run two parallel sessions of save. Now we choose File menu. Now choose File menu, Import save.f2k. Import model A. Choose Set Display Options and remove horizon. Uncheck invisible points, and now you can see that the points are there and with the loads applied. Okay, in the same fashion for model B, again use File, Import save.f2k file and import model B. Now you will notice that this corner point is missing. Now you can take a note that that above, earthquake B above, earthquake Y B above is there. Currently there is no live load coming up in this particular model. So, but we are not so much concerned about that, because we have to just to show you how to work and how to combine these two building models in one safe model for the purpose of basement design. Now take note that the origin of this model B is 0, 0. So what we do, we select everything and then we choose edit, move. We move it by 24.5 minus 4. Now this point is in its new position. Now go back to model A. We are going to save it in the name as combined model. Here we are going to use two more load patterns. EQXB above of type quick, and we define one more name should be identical in the two models. Okay, then dead and live are alright. Dead above, live over, that's fine. There is no issue with that. And we press OK. Now we choose edit, interactive database editing, geometric data, point coordinates. We take it to Excel, and this is book 1. Now in the second model we choose edit, interactive database editing, point coordinates. Now select everything and go back to the previous workbook. However, caution should be injected here that the point text is same as before. So what we can do, we can add B at the end of the joint labels so that two joints with the same label do not exist. Although there are other options also to hasten this process, like for example you can use concatenate command of Excel to create this sort of change in the text of the labels. Okay, now select the cell and delete it. Finally, select these and go back to the previous one. And here paste it, because we need to change the labels in our model 2 also, so that when we are importing the loads, then loads are relevant to the new and revised labels of the nodes or joints. Now press escape. So now we see that we have added these different new joints. Go back to model A and now take it from Excel. Now it shows apply to model, done. And now you can see that these two models are coming up in the same safe model. Finally, we are going to use the same process in model number B. Apply. We are going back to again combined model and choose edit, interactive database editing. This time choose assignments. And choose these 4 load cases. Press OK. Now you can recognize that all these loads are coming up. Now press to Excel. Now this is the Excel sheet of combined model. We go back to model number B and again we choose edit, interactive database editing. This time we choose assignments, point loads. And we choose these 4 load cases. Now choose to Excel. Copy this worksheet. To combine model. And now this combined model will be having the loads of both the models. Now choose from Excel, apply to model, done. Now on this point, see the loads dead above, earthquake B above, earthquake Y above. And here you can see it is dead above, earthquake X above, earthquake Y above. So now by using this small exercise, we have been able to combine the 2 models together. Next, we can choose define menu, slab properties. We can choose some value 600 mm. Slab material, if you want to change, you can. Next, we draw the polygon. Now you can expand it if you want. Now this edge is approximately 1.4 meter away from the point. So we can move it now. This is having 2800. If you want to further change it, if you want to combine it with the, if you want to align it with this edge, so now we see that all the points are existing at the edge of the basement. This does not look realistic. We can select the area and we can choose expand shrink areas, and we can expand the area by 2 meters in all directions. Finally, we choose the area object and choose edit. We choose assign support data and soil properties, and we assign it soil properties. Now please take a note that the earthquake loads may act for building model A and model B. Both are moving in the same direction towards right or towards left, or the two buildings may move towards each other or may move away from each other. In the same way, in the y direction, these two buildings may move together upwards or together downwards, or one building may move upwards, one building may move downwards, and the other may move downwards, and the next one can move upwards. So all these permutation and combinations we can generate by using define menu, load combinations. Now suppose we see that both buildings are moving towards each other, then we can give it as say -1. Then both the buildings are moving towards each other. Or if both the buildings are moving away from each other, then just by changing the signs, we can change it. Okay. Next thing is defining these design strips. That is very simple task. You can choose any kind of design strip you want. Similarly, other design strips can be drawn. We can run the model, and if you want to see the strip forces, then we can see these in the conventional form. So now you can see that in this small movie clip we have shown you how two different models can be combined in one safe model with a great degree of comfort and ease. This concludes this tutorial.